Right now, as you watch this, there is a human-made object traveling through a region of space so remote that the word far doesn't come close to covering it. It is not in our solar system anymore. It crossed that boundary over a decade ago and kept going. No destination, no instruction to stop, no one waiting for it on the other side. It is moving at 38,000 miles per hour through a darkness so complete, so absolute, so incomprehensibly empty that the nearest star to it won't be near for another 40,000 years. It has been flying since 1977. It was built by human hands in a decade when the most powerful computer on Earth had less processing power than the phone in your pocket. It runs on decaying plutonium and sends signals home that take over 22 hours to arrive, traveling at the speed of light, and it is dying. Slowly, piece by piece, system by system. And when it finally goes dark, when the last signal stops and the silence becomes permanent, it will become the loneliest object in the history of the universe. There's a photograph that Carl Sagan spent years convincing NASA to take. He lobbied for it. He argued for it. He understood, with a poet's certainty before the image existed, what it would mean. On February 14th, 1990, Voyager 1 turned its camera backward, one final look over its shoulder at the solar system it was leaving, from a distance of about 3.7 billion miles. Earth appeared in the image as a single pixel, not a planet, not a sphere, a mode of light, suspended in a beam of scattered sunlight against a backdrop of absolute black. Sagan called it the pale blue dot, and the words he wrote about it are among the most quoted in the history of science, because something about that image broke something open in the people who saw it. The smallness of it, the fragility of it. Every war ever fought, every empire ever built, every person who ever lived, all of it contained in a pixel so small that it barely exists. It was one of the most beautiful things humanity has ever produced. And then you realize what was on the other side of the camera. A machine the size of a small car, built with 1970s technology, alone in the most hostile environment that exists, racing away from the only world it ever knew, with no way to turn around, no way to stop, and a power supply that loses 4 watts of energy every single year, falling, not toward anything, just away, forever, into a darkness that gets darker the further it goes, in a universe that does not register its existence at all. That's not beautiful. That's something else entirely. That's the closest thing to tragedy the cosmos has ever produced. Voyager 1 is currently more than 15 billion miles from Earth. That number means nothing to the human brain and everything to the human soul if you sit with it long enough. Try this. Light, the fastest thing in the universe, the speed limit of reality itself, takes 8 minutes to travel from the Sun to Earth. It takes 4 hours to reach Neptune, the outermost planet. It takes over 22 hours to reach Voyager 1, 22 hours for light to travel that distance. When mission controllers at NASA's Jet Propulsion Laboratory in Pasadena send a command to Voyager, a command that travels at the speed of light, they wait 22 hours for it to arrive, and then another 22 hours for confirmation to come back. A 44-hour round trip for a single exchange, a conversation conducted in silences that last almost 2 days. And in those 44 hours, Voyager has moved another 3.3 million miles further away. Every command sent to Voyager 1 is a letter to someone who has already moved since you wrote it. Every signal received is news from a past that is over a day old by the time it arrives. The engineers who communicate with Voyager are not talking to a spacecraft. They are corresponding with one, across a distance that grows by over 1 million miles every single day and accelerates with every hour. But here's the problem. The distance is not what will kill it. Voyager 1 doesn't run on solar power. You already knew this somewhere in the back of your mind, because the Sun at 15 billion miles away is not a star anymore. It is a bright point of light. Brighter than other stars, but not by enough. Solar panels out there would be useless. Instead, Voyager runs on 3 radioisotope thermoelectric generators, essentially small nuclear batteries powered by the radioactive decay of plutonium-238, converting the heat of decay into electricity. When Voyager launched in 1977, those generators produced about 470 watts, less than 5 standard light bulbs. That was always the budget. Everything Voyager has ever done, every photograph, every measurement, every signal sent home across billions of miles, was accomplished on less electricity than it takes to run a small appliance in your kitchen. And plutonium-238 decays at a fixed rate, unavoidable, immutable. The physics of radioactive decay are not negotiable. Every year, Voyager loses approximately 4 watts of power. It doesn't sound like much, but Voyager is currently generating only around 249 watts, barely half of what it started with. And as the power budget has shrunk, NASA has been forced to make a series of decisions that feel less like engineering and more like triage. The camera was turned off in 1990, right after the pale blue dot photograph, not because NASA wanted to. because the camera required power that could no longer be spared. Then the plasma wave subsystem was reduced. Then heating systems were shut down to prevent entire instruments from freezing in the cold, not because space is cold in the dramatic way, but because at those temperatures, without heat, electronic components crack and fail. One by one, the systems that made Voyager what it is have been powered down, mothballed, sacrificed to keep the remaining instruments alive a little longer. But it gets worse. The temperature of interstellar space and the space between star systems, the space Voyager now occupies, is approximately negative 270 degrees Celsius. That is 3 degrees above absolute zero, the lowest temperature physically possible in the universe, the point at which atomic motion itself approaches stillness. Voyager was not designed to operate at absolute zero indefinitely. It was designed to survive long enough to study the outer planets, a mission that was supposed to last 5 years. 5 years. The engineers who built it are, most of them, dead. The technology inside it belongs to a world that no longer exists. The computer memory on board totals 68 kilobytes. A modern smartphone has roughly 100 billion times more. The code running Voyager's systems was written before the internet existed, before personal computers existed, in a programming language that barely anyone alive today still knows. And yet it flies, it measures, it transmits. Against every expectation, against the cold and the distance and the age of its own components, it persists. But the cold is winning. NASA engineers discovered in 2023 that one of Voyager 1's flight data system computers was sending back corrupted data, garbled signals that looked at first like catastrophic failure. The team spent months diagnosing the problem across a 44-hour communication delay. Like surgeons operating on a patient they can only examine through messages that take a day to deliver. They eventually isolated the issue to a single corrupted chip in the flight data system, a chip they could not replace, could not touch, could only route around, reprogramming a 47-year-old spacecraft from 15 billion miles away. They did it. It worked. But the chip is still corrupted. The workaround is fragile. And the cold is still out there, patient and absolute, pressing in on components that were never meant to last this long. And this is where things change. Voyager 1 crossed the heliopause, the boundary where the sun's solar wind is finally overwhelmed by the pressure of interstellar space, in August 2012. It became the first human-made object to enter interstellar space. That sentence looks like a triumph. It is a triumph. It is also the moment Voyager stepped off the edge of everything we knew and into a region we had only theorized about. What Voyager found when it crossed the heliopause was not nothing. It was something we hadn't fully predicted. The density of the plasma, the ionized gas filling interstellar space, was higher than models suggested. The magnetic field direction was different from expectations. The cosmic ray environment shifted abruptly at the boundary, as if crossing a threshold into a different room. Voyager didn't just confirm our models, it complicated them. It revealed that the edge of our solar system is stranger than we thought, and that the interstellar medium, the vast ocean of space between the stars, operates by rules we are still working to understand. Right now, Voyager is the only instrument humanity has ever placed in interstellar space. It is the only source of direct measurements from the environment between star systems. Every piece of data it sends home is information that cannot be obtained any other way. There's no second probe waiting to take over. There is no backup. When Voyager 1 dies, we go blind in interstellar space, possibly for generations. But that's not even the worst part. The engineers at JPL who still communicate with Voyager are working against a deadline that physics has already set. Sometime around 2025, the power budget will drop below the threshold required to operate any scientific instrument at all. The instruments will be shut down, one by one, until Voyager is flying in complete darkness, still moving, still transmitting a carrier signal if power allows, but no longer measuring, no longer seeing, no longer telling us anything about where it is or what it's passing through. And then, sometime in the late 2020s to early 2030s, the exact date depending on how carefully the engineers manage the remaining power, how many more workarounds they can coax out of a 47-year-old machine from 15 billion miles away, the transmitter will fall silent. The signal will stop. And Voyager 1 will become a ghost, a physical object still traveling through interstellar space at 38,000 miles per hour, still carrying the golden record bolted to its side. A 12-inch gold-plated copper disc containing sounds and images of Earth, greetings in 55 languages, music from Bach to Chuck Berry, the sound of rain and wind and surf and a mother's first words to a newborn child. Still flying, but silent, unreachable, gone. It will pass within 1.7 light years of a star called AC +79 3888 in approximately 40,000 years. That is the closest it will come to any star for as far into the future as our orbital mechanics can calculate, 40,000 years, by which point every language on Earth will have changed beyond recognition. Every civilization currently existing will have risen and fallen and risen again, and the star it passes will never know it was there. Voyager will travel through the galaxy for billions of years after its last signal, long after the sun has exhausted its fuel and expanded to swallow the Earth, long after humanity has either spread across the stars or disappeared entirely. It will still be moving, unchanged, unbothered, carrying its golden record through the dark, a message from a species that no longer exists to a recipient that was never guaranteed to receive it. Carl Sagan understood something when he lobbied for that final photograph. He wasn't just asking for a picture, he was asking for a mirror. He wanted humanity to see itself the way the universe sees us, which is to say, barely. A pixel, a mote, a flash of organized complexity on a rock in the outer arm of an unremarkable galaxy, significant only to ourselves. Voyager 1 is the physical extension of that impulse, the longest reach human hands have ever made. We launched it before most people alive today were born, and it is still going, still measuring, still sending home its whisper of a signal across a distance that light itself takes almost a day to cross. We built it with slide rules and punch cards and the sheer, irrational confidence of a species that had been in space for exactly 16 years and decided that wasn't far enough. There is something about Voyager that is specifically human, not in a triumphant way, in a melancholy way, in the way that the most human things we do are not the conquests or the monuments, but the small, stubborn, reaching things. The message in a bottle thrown not into an ocean, but into the galaxy, with no real expectation of reply, but with the desperate, beautiful need to have reached at all. When the signal stops, when the last carrier wave fades below the noise floor of our most sensitive antennas and mission controllers sit in a room in Pasadena knowing that the silence is now permanent, Voyager will not know. It has no knowledge, it has no experience, it is a machine, but it will keep going. It will carry that golden record into a darkness so profound that the universe will not notice it passing through. And yet, we will have sent it. We will have reached. We will have taken our best materials and our most careful science and our most sincere hope, the hope that there is something out there capable of receiving what we sent, and we will have thrown it outward with everything we had. Not because we were certain it would work, because we couldn't bear the alternative. The universe may be empty, but we sent a record. We put music in it, and somewhere in the dark, between stars that will never know we existed, it is still playing.